Hello, in this video we are going to talk about how do we graph a function using all the things we learned, like using the finding the x-intercept, y-intercept, critical points, local max, local mean, asymptotes, point of inflection, increasing interval, decreasing interval. We use all those things to draw the graph of a function. Okay, so we may not have to find out everything that I just mentioned, but most of the time we find out most of those. Okay, before we go to the sketching of the graph, let us talk about how do we guess, how do we find out the graph of the derivative function for a given function. For example, in example number 1, see, the blue curve represents the graph of fx, and then the blue curves here are the graphs of f prime of x. So we are trying to find out which of these graphs is the graph of the derivative of this function. Okay, so how do we know that? Is the best idea is we want to find out where the graph is increasing and where the graph is decreasing. Okay, you can see that left of 0 the graph is increasing, right? When the graph is increasing, when f is increasing, then f prime will be positive, right? And if f is decreasing, then f prime will be less than 0, negative. So we'll try to find out. Look at this graph. From the graph you can see that that's not right. So from the graph of fx you can see that the derivative function will be positive on the left because it is increasing, right? And then negative on the right of 0 because it is decreasing. So is this the right graph? No, because see, on the left of 0 sometimes it is positive, sometimes negative, and then sometimes positive. So this is not the right graph. How about this one? The graph is positive left of 1, but we need the graph must be positive left of 0, not left of 1. So this is not the right answer. This is negative everywhere. So meaning the graph must be the function must be decreasing to be this as the right answer, right? So let's see this one. On the left of 0 the graph is positive, on the right of 0 the graph is negative. So which matches this description, right? The left of 0 the graph is increasing, right of 0 the graph is decreasing. Decreasing means f prime must be negative. So this is the right graph. Let's see this one. What you see here is the graph is increasing on left of 1, right? This is 1, this is 2, and then the graph is decreasing between 1 and 2, meaning what do we need is f prime must be positive, right? When the graph is increasing the derivative must be positive, x less than 1, and it is negative when x is between 1 and 2, right? 1 is less than x is less than 2. So this is what it should be. Let's see which graph matches this. On this graph f prime is positive and then negative as well, left of 1, right? So this is not the right graph. How about this one? F prime is positive and left of 0, but we need the f prime positive left of 1, right? Because it is increasing up to 1. So this is not the right graph. How about this one? The graph is positive left of 1, right? This is left of 1, and the graph is negative between 1 and 2. So this is the right graph. The fourth is not. This is not the right graph because the graph is negative everywhere, meaning the function must be decreasing everywhere. Okay. So this is how we find out the graph of the derivative function for a given function. The next thing we discuss is the sketching graph. So how do we sketch the graph? We first find out the x-intercept, y-intercept, critical points, local max, local mean, asymptotes, points of inflection, everything that we know. And again, the calculator, if you plot that in the calculator, it plots right away, right? But we are interested to do by hand. So the first thing let's try here is, for this function I want to draw the graph right here. But what are the x and y intercept? Do you remember how do I find out y intercept? For y intercept, you do x equals to 0, right? X equals to 0. If you take x equals to 0, what do you get? Y, because fx is basically y, equals to 0 plus 1 over 0 minus 9. That means negative 1/9 is the y intercept. How about x intercept? To find out x intercept, you said y equals to 0, right? So you said y equals to 0. What do you get? So 0 equals to x squared plus 1 over x squared minus 9. So you because there is 1 in the denominator, you can do the cross multiplication. You get 0 times x squared minus 9 is 0. So you'll get x squared plus 1 equals to 0. So if you solve it, you get x squared equals to negative 1. So which will be imaginary, right? So we are not interested on the imaginary values. So meaning that there is no x intercept. So no x intercept, because we got imaginary values. Okay, no x intercept. We got the y intercept is negative 1/9. Negative 1/9 is almost 0. Meaning what we expect is the graph intersect close to 0. Close to 0, right? That's what the graph intersect there. Now let's find out the vertical and the horizontal asymptote. How do you find out the vertical asymptote? Do you guys remember that? To find out the vertical asymptote, you get the function in the lowest form, meaning if there is anything common, you get rid of that, cancel that, and then solve the denominator after that. So since it is already in the lowest form, there is no common factor. So you solve the denominator to find out the vertical asymptote. So what you do is you do x squared minus 9 equals to 0. So what do you get? X squared equals to positive 9, right? Add 9 on both sides. So take the root. What do you get? X equals to plus and minus 3. These are the vertical asymptote, right? So let's go to the graph and then see. This is, let's say this is negative 1, negative 2, negative 3. So this is the asymptote, vertical asymptote. So the graph never crosses these lines. And another is 1, 2, 3. So this is another vertical asymptote. These are the vertical asymptote. X equals to negative 3 and x equals to positive 3, right? How to find out the horizontal asymptote? Do you remember that? Horizontal asymptote is similar to finding the limit at infinity. So what is the degree of the top? Is 2. Degree of the bottom is 2. So they have the equal degree, right? So what is the horizontal asymptote? Horizontal asymptote will be y equals to, what you do is you find out the ratio of the leading coefficient. Here the leading coefficient is 1, here the leading coefficient is 1. So 1 over 1 is 1. So y equals to 1 is the leading coefficient. So what we do is the horizontal asymptote is y equals to 1. This is y equals to 1. So the graph does not cross this one too. So it looks like, see, the graph will go like that and the graph will go like that. It looks like that because it does not cross this, does not cross this, does not cross this, does not cross this. Or you may go like up like that too. That is another possibility. Or like this, or like this. So we don't know it, right? We will do more things. So relative extrema. To find out the relative extrema, what we do is you try to find out the point of critical points, right? How do I find out the critical points? To find out the critical points, first we find out. Let's find out critical points, critical numbers. To find out the critical numbers, you find out the first derivative, right? So how do you find out the first derivative? To find out the first derivative, you use the quotient rule. So what we use is the derivative of the top. It is like f over g, right? So f prime times g. F prime is 2x times the g is x squared minus 9. So it will be x squared minus 9 minus f is x squared plus 1, and then times g prime is 2x divided by x squared minus 9 to the square, right? So if you simplify this, what do you get? So f prime, you get 2x cubed, and then here you will get 2x cubed, right? So it will be like 2x cubed minus 18x, and then minus 2x cubed minus 2x divide by x squared minus 9 square, right? So what you get, you cancel that 2x cubed and 2x cubed. So basically what you get is f prime is equals to negative 20x divided by x squared minus 9 to the square. So to find out the critical points, you said that equals to 0, right? Since there is a fraction, you just solve numerator equals to 0 and denominator equals 0 to find out the critical points separately. So what you get is the possible critical points are x equals to 0. If you solve the numerator set equals to 0, you will get x equals to 0. If you set the denominator equals to 0, you will get x equals to, so x squared minus 9 equals to 0, right? That's what you get. So from here you get x equals to 3 and negative 3 if you solve that. So these are the possible critical points. But you see that at 3 and negative 3, since there is a vertical asymptote, so these are not the critical points, only x equals to 0 basically. Or I would say these are also the critical points, but this critical point does not fall in the domain, right? Because it is not defined at 3 and negative 3. So we don't worry about that. So x equals to 0 is the only critical point we are interested, right? So what we do is you find out the second derivative and then check whether x equals to 0 has local mean or local max. So if you find out the second derivative, what you do to find out the second derivative, again you do a quotient rule, okay? So actually I found out the second derivative for you guys. If you find out the second derivative, you will get 20 and then 3x squared plus 9 divided by, you get x squared minus 9 to the cubed. That's what you will get, okay? If you find out the second derivative using the quotient rule. Now what we do is you want to find out where this x equals to 0, whether x equals 0 give you maximum or minimum, okay? So how about plugging in that at x equals to 0, you got f double prime is equals to 20 times 3 times 0 square, right? That will be this will be 0, right? This will be 0 and this will be 0 as well. So what you get is 20 times 9 is 180, right? Divide by negative 9 to the third. Negative 9 to the third will be negative number, so it will be negative, right? So this is negative, means at x equals to 0, f of x has local max, right? When the second derivative is 0, it is like a cup, the concave downward, right? Meaning that local max, this point will be the local max. So it looks like the graph will be like some kind of like this, right? Like that. The graph will look like this, because this is the asymptote and this has a local max at x equals to 0. This graph is not very good, but I think it will go like kind of like this, symmetrical kind of. Now if you find out the and we don't know whether there is a graph on this side outside here or outside here, we don't know it, right? So let's find out where the graph is increasing and decreasing, okay? And then we can find out the point of inflection as well, but it involves solving the second derivative. When you solve the second derivative, you don't get any point of inflection there, because there is no x value that gives you real number. So let's not do the point of inflection. We cancel the point of inflection for now. Sometimes if it is easy to find out the point of inflection, you can find out, but here there is no point of inflection, so there is no concave up graph basically. Okay, so how do I find out the increasing and decreasing interval? So what we do is we find out we plug in the critical points, right? So what were the critical points? One critical point was 0 and one was negative 3, another was positive 3, right? And then we find out the sign of f prime of x. So f prime, what was the value of f prime? F prime was negative 20x divided by x square minus 9 square. Since this is square, you don't have to plug in into the denominator because you always get positive values. For any x value, you will get positive on the denominator. You just plug in on the top. Okay. If you take a test point, say -4, what do you get? So you get -4 times 20 is positive 80 over positive 1. So it will be positive, right? So you will get positive. So basically the graph is increasing here. You see like that. Let me take a test point here, say -2. If I take -2, -20 times -2 will be positive 40, and -2 square is positive 4 minus 9, but square. So the denominator will be positive all the time. So the numerator you got positive. So it is also positive. So you get like that. How about at this point? So it is positive 2. -20 times positive -40. The denominator will be positive again. So negative. So meaning the graph is decreasing. Similarly, if you take 4 as a test point, so it will 20 times -20 times 4 is -80 divided by positive number. So it is also decreasing here. See, we have seen already that the graph is increasing between this is -3. On this piece, the graph is increasing. We draw that already, right? On this piece, we need to find out the graph is increasing here, and this piece decreasing. We know that already. Now the idea here is that the graph is above x-axis, the graph is like this, or the this is not possible, right? Because the graph will be decreasing. So we need the graph increasing. Is the graph like that or like this? Anyway, so how do I know that? Is let's take at -4. At -4 is the function above x-axis or below x-axis? At -4, let's see. -4 square is positive 16 plus 1 is 17 divided by -4 square is 16. Positive 16 minus 9. So it is positive. The function will be positive on the left side of -3, meaning the graph looks like this, right? And then at positive 4 it is positive as well. So the other part of the graph looks like this. So the graph look like this. So this is how we draw the graph.